right? Point 5, with the center at C, scribe an arc with a length of 3 meters representing the true length of OC. Right, here's C. So you'll have to set your compass to 3 meter length here, this OC, 3 meter. Then we set the compass out to 3 centimeter, and then we'll draw an arc. So where those two arcs meet, this arc from 3 meter, this arc from this length here, from there to there is unknown, but you'll measure it after projecting here. So where they meet will be what? Will be point O, will be point O. So point number 6. This intersection will be the apex O. Then point number 7, complete the top view. So what we have to do here, go draw, project this thing downward like that. And then where that dotted line meets with the horizontal line, then we can just join this thing like this from here to point O, from here to there, from there to there. Then we are done with this, the first structure. Draw the force diagram shown in figure 1.5 with vertical line representing the force, whatever. You can read there, I will explain it on the next page. Okay. So if you still remember very well, this one, get the front view. So get this thing. When you look at it from directly, or the front, directly from this. So this one is not actually the front view, it's like a 3-dimensional. If you look at this thing from here, you won't see these two, you won't see them at the same time. You'll only see this one. So that's why we've got A and B here, because if you look this thing directly, you'll only see B, you won't see A. A will be behind B. So this is the very same view. It's just that this one is straight. So this one go OC, this one, and that one get that one OL OB. Right. What do you have to do if you still remember from strength and 5 frameworks? If you know something like this, to draw the force diagram, we have to start with the unknown force, known force, or the external force. So I'll draw this line, represent this one. So it's up to you, you can use any scale there. After drawing this line, I could change to scale or draw a parallel line. So draw a line parallel to this, So this line, it's parallel to this. Or draw a line from this end point parallel to this. After that, or draw another line from here parallel to this. So this line, this one, it's parallel to that. So this angle here, this one must be the same angle as this one. Right, this angle here must be the very same angle here. This angle must be the same as this one. So get the parallel lines. It's just that I didn't get time to show you an alternative method, but here you'll need product. You have to measure this angle, and then draw those things there. Right, hoka check either or through either end. So they're just referring to this. You can draw this line here. This line, you can draw this line here. And then this one, you can draw it like this. This line is still parallel to this. This line is still parallel to this. So you'll get the same answers. So if you don't want to use this black one, you can use this pencil one. You'll get the same answers. Right, number 9. Draw horizontally a line to scale representing length OA in the force diagram as shown in figure 1.6. Here's figure 1.6. So what we have to know here is that this one OC, because OC is the true length. OC is the true length. The distance from here to here will represent what? Will represent the force in OC. This distance from here to here will represent, from here to there, will represent the force in OA and AB. But this one is not OA or OB. It's not the true length. This thing is not the true length. Remember this thing aim like this. This calculator is at an angle. I'm not sure if you will see that part, but it's not straight. If it's straight like this, so if I put it at an angle like this, when someone views that calculator directly, when I'm saying directly, I'm referring to when I look at this thing horizontally, not the view that you are seeing from the camera, because the camera I'm taking it from the top. So if you view this thing horizontally, you know, horizontal line, the length of this calculator will appear as if it's like this. So the length will appear as if like this. It's because this calculator is at an angle. But in reality, we know that the length of calculator is like this, is from here to there. In reality, we know that the length will be this size, will be very long, get this one. But if you keep the calculator like this at an angle, it will appear as if you look it horizontally, it will appear as if the length is this size. So because this length is at an angle, that's why we say the length that you are going to see when you observe directly, it won't be the true length. It won't be the true length. So because that length is not the true length, that means this force, the force that you are going to get there, won't be the true force for those members, for member OA and AB. So that force is the resultant force. So now I'll show you how to get the true force in these members AB and OA. Right, we'll start to measure this length from here up to there. From here up to there. If the length is 4 centimeters, you will have to draw a horizontal line like this from here to there. That line must be 4 centimeters. The 4 centimeters from where is from this. Measure this length from here to there. If the length is 4 centimeters from here to there, then we have to take that 4 centimeters, draw more horizontal. Then after that, this sketch we know it, we've drawn it before. This part, the same sketch. So Ojeraing from this point, or draw a line parallel to what? Parallel to this line. This line parallel to this. Then from this other end, from this, or draw a line parallel to this. A line parallel to this. So that's why you see here, but throw either end. So if you don't want to use this, you can use this one with the pencil. You can still draw this line. Why start damo? This pencil line is parallel to this. Then from here, we'll draw this line. This line is parallel to this. Then after that, you will measure these distances, BD and AD. Therefore, these distances, they will give you the forces in the members. So this one, AD, which is this one, will give you the force in member OA. This one, which is this, will give you the force in member OA. This one, which is this, will give you the force in member OB. Therefore, after measuring, and then after that, remember, we have to convert according to scale to Newton. You will find that OC and OA and OB will be 2.28. Remember, this one OC is from this, and then this one OA and OB is from this one and this one. Thank you very much.